Pleasant day, everyone. By the way, this is our seventh topic, I think, in Chem 36, and this is about chirality. What do you mean by chirality? So chirality has something to do with similarities. As you can see in the picture, they are similar or they are alike. Okay, the other one looks from the left side, looks the same with the right side. And this is what we are going to discuss today. It has something to do with similarities. So this topic is about chirality. So as you can see here in organic chemistry, okay, this is Samuel Jackson, but of course, his position is to the left, okay? While this one is Samuel Jackson, but his position is to the right. So this is known as levorotatory, okay? That is in organic chemistry. This is dextrorotatory in position. So let us look more deeper, what do you mean by levorotatory and dextrorotatory? What makes them alike, no? And what makes them different? Okay, so this is a monkey. Of course, it has no similarities with the other one. What my differentiation here? Okay. So this chapter is about chirality. What do you mean by chirality? It has something to do with the handedness of molecules. What do you mean by handedness is where will it turn? Okay. And what will happen if it turns to the right or to the left? Will its structure be the same? Okay. So that is what is meant by this chapter. It has something to do with chirality. As you can see here, this is a shell. Okay, so this shell is taken in the median cross, no? So in the deep waters of the Pacific Ocean, this is a chambered nautilus. Okay, as you can see, it has ang iyang mga spiral has its handedness. Where will it turn? It turn to the left. Okay, so there are also shell wherein its handedness, its cross section turns to the right. Okay, so this is our topic this today. So the key questions, the main objective of this lesson is we are going to define what is enantiomers. Enantiomers are mirror image. Okay, as you can see here, this is my left. The mirror image of my left hand is my right hand. Diba? This is the left and the right. Hold them apart. So clean and bright. What I love what? So that is enantiomers. Let us look what makes it enantiomers, meaning its mirror image, this one. Same thing with identical twins. Kanang what do kay ma-differentiate, no? There are two types of twins, the fraternal and the identical. What do you mean by identical? Identical twins, it comes from one, no? Okay, it comes from one eggshell and two, no? Two sperm cell, and it's split into two. Okay, but for fraternal twins, that is why in identical good, meaning they have the same features. But in identical, if it is both boys yun na siya, both boys and both girls. It could not be boy and girl. No? Unlike in fraternal twins, it has two eggshell, no? And two sperm cell. No? So what happened is it is fertilized into two, no, different sperm and egg cell. Okay, so that is why there is a tendency in the fraternal twins na dili siya samukan eh. Okay. Dili siya pareho, no? No, di sila pareho og noun. Why? Because it comes from two different sperm fertilized egg na. It comes from two fertilized egg. Okay? So that is what is meant by fraternal and identical. So, enantiomers are mirror image. What do you mean by mirror image? The identical is a mirror image of the other one. Okay. So, how are we going to draw enantiomers? So, what are stereocenters? This is what we are going to discuss further in this topic. Then, how many stereoisomers are possible in a molecule? No? Then, what is optical activity? How it will turn? No? The turning of the molecule to the right or to the left. Okay, and how it is being detected in the laboratory, its chirality. And of course, what is the significance of this chirality in the biological world? So what are enantiomers? As I have said, enantiomers are mirror image. If you look into this, no, this is cis-butene and this is trans-butene. No? So, cis-butene, how will you know it's cis? Diba? Ingon ko sa inyo kung cis gani siya, no? Butene is na 4 carbon. Diba? 4 carbon. Okay. But in cis-butene, what happened is it is in same up, no, same side siya. Is it up or is it down? The trans is opposite. It could either be your CH3 here, then CH3. The other one, pwede po ganun CH3, CH3. Here in the cis-butene, it could be on the top or it could be down. Okay, so these are relationship among isomers. Okay, so what do you mean by this enantiomers and diastereomers? So let's dig more deeper about this. So this one is cis-1,4-dimethyl cyclohexene. Na? Then this one is trans-dimethyl, na? Trans-1,4-dimethyl cyclohexene. Okay, this one. Okay, so its relationship is they are isomers. What do you mean by isomers? Isomers are molecules, okay, that they have the same molecular formula, but they will only differ in its structure. The same molecular formula, good, because take a look. This is in a cyclohexane added with duhaka methyl. So cyclohexane also duhaka methyl. But what happened here is it is in the cis, meaning same side. Nga niya nga side or nga hipon nga side. Okay, that is cis. Kani is trans. Nga naman, how will you know it's trans? Basta nagani kaning ingani kanang sa pangani kanang nag broken line, meaning tuana siya sa opposite. Na? Kani is tuana siya. Kung tanaw ni mo siya, tuana siya sa likod. Okay, that is it. That is why it's so called trans, meaning opposite. So, these are mirror image. Mirror image. Therefore, okay. Therefore, let us look into if what do you mean by isomers? Meaning, as I have said, isomers are they have the same molecular formula, but they will differ in its structure. That is what is meant by isomer. So if the isomer has the same connectivity, therefore they are stereoisomers. But if they differ in connectivity, they are constitutional isomers. So if it is a stereoisomers, paghapon classification into a chiral or chiral. What do you mean by a chiral? Without a chiral are without stereo centers, while chiral it has stereo centers. And in the achiral, duha ra gyud ka klase katong gipakita ganina, the cis and the trans isomers, no? So, in the chiral, it could either be enantiomers, meaning mirror image. The other one is diastereomers. As I have said, so in a chiral, how will you know it's a chiral? If it is without stereocenters. So many stereocenters, ma'am, na kaya ito na i-discuss, no? In the next slide. Tapos kung with stereocenters gani siya, is chiral and it has two forms. It could either be enantiomers, meaning mirror image, and the other one is diastereomers. Diastereomers. Okay. So this one, this is 2-butanol. No? Why it's 2-butanol? Because it is an alcohol. Take a look. This 1, 2, 3, 4. So it's 4 na siya. It's butane. But there is an alcohol at carbon 2. That is why it's so-called 2-butanol. Okay. So if we are going to have this in ball and stick model, kaniwala ni siya, the ball and stick model. This is the first carbon, no? Second, third, fourth. This is now your OH. Okay. So this is the original molecule, no? Pero imo gani ni siyang tan-awon sa mirror, na kani-kani nga molecule. Mao na ni mahitabo, mao na ni makit-an nimo, no? This is the mirror image. Instead of OH, it will be HO, no? Tapos kani nga bulk kani kani mo transfer nga to speakers because it's a mirror image. Okay. So this is the original molecule. This is the mirror image. So if we will have it in a ball and stick, kani musa katos ibabaw, no? Then same ra gihapon, no? Kani. Actually, kani siya maoy tuana sa kilid, na? Sa kilid. That's mirror image. Kani siya ngani ang molecule, the carbon here tuana sa kilid. Then this is your CH3, na? Then kaning duha ka CH3, CH2, CH3 nganhi na pud siya mos na ana po ngani asa because it's the mirror image. No? So what is the relationship between the original molecule and the 2-butanol in its mirror image? What is the relationship? It's still the same. No? It's still the same. But what happened is the bulkiness is already on the left side. Here, it's on the right side. Okay? So if it is superposable, no, there are two types of mirror image. It is superposable, or that is known as superimposable, no? Kanina lang. Superposable, meaning the mirror image and the original represent the same molecule. They are merely oriented in different space. Same thing with what we have here. Kani, na ang orientation lang niya is it's the same, na, but what happened is it's the orientation in space. The bulkiness of your CH2 CH3 is on the right side, but if it is its mirror image, the bulkiness of the CH3 CH2 is on the left side. Okay. So that is superposable. Okay, meaning the mirror image and the original represent the same. Okay, so what happened if the mirror image, no, is not exactly fitted to its original, no? Every detail matching, then the two are non-superposable. Meaning, no, for instance, if this is the molecule, kanimo ni ang molecule, the superposable is imo gani siyang i-fit in. No? That is why my mirror, my left hand and my right hand are not superposable. Ngano man? Because if you are going to fit in, ana, di siya mag-abot. Here, dili mag-abot ang imong left or right hand. No? So that is not superposable. It is non-superposable. But what happened if it is your right hand and your left hand will not fit in? That is what is meant by superposable. Okay. So that is what is meant by superposable and non-superposable. So superposable is the molecule will fit in. Kung imo siyang ipasulod, what will happen is it will fit in to the molecule. But if it will not fit in, meaning it is non-superposable. Okay? Okay, so here, this is now your original molecule. This is the mirror image. Okay, so if you are going to rotate this COH into 180 degrees, what will happen? So this is now your mirror image rotated at 180 degrees. So the mirror image is this one. Okay. If you look into the original, pag rotate mo, is it superposable? Yes, kay pareho gyud sila, na? Okay. So, this one is superposable. Okay? Because its mirror image has the same nga molecule, na? The same ang formation sa iyang molecule. Okay? So this is the original molecule, and this is now your mirror image. What makes it differ is only the positioning of the H. Di kanid ba? The positioning of the H. So here it is. It is superposable. This is your ball and stick. This is the mirror. And this is the ball and stick of the original. So same thing with kaning magkuha kag screwdriver. Okay, so what happened is the kaning isud nimo ang screw, what will happen is if it will have the same groove, di ba? So it will have the same groove. So this is the same with the threads of the screw along with the axis of the helix. This has some characteristic with plants. This is the screw, diba? The same ang helix gud niya. Okay. Same thing with kaning mga plants nga which will climb. Okay. If you look into its tendrils, kani. Ang pagka grabe gyud ang grabe gyud kuan ang even plants has its own pattern, so ang pattern niya kani ang iyang pag climb niya, what will happen, the twisting of the thread of this plant, it has the same gyud siya tanan kani pag katay labaw na ganang mga climbing plants, vegetables such as batong, di ba? Pag tan-aw nimo sa ilang kinatayan, maura gyud, So it shows, tapos it has the same pattern, left hand twist, the same with the tendril of the right hand twist, So kung left hand siya tanan, right hand po tanan siya. Okay. So we have two wood carvings here in letter A. Okay. So the mirror image cannot be superimposed to the actual. So if this is the picture, which is the mirror image of this, the wood carvings here has the same features, the same ang iyang position, the same ang iyang ang pagkahimo. Pero ang problema is its mirror image cannot be superimposed, So it is non-superposable, kani o kana imo siyang pasulod, di gyud siya masulod kay because it is not superposable. So the man's right arm rest kani mo di ba ang ngani siya ang right arm niya hingrest ngadto sa camera kani, while this one its left hand rests to the camera. So that is why you could not superimpose this statue. Okay. Now, while this one, this is the picture that we have. This is a shell. Okay. So it has a left and right hand seashell. Take a look. Na? This is kaninga niya is the left hand. This one is the right hand. Na? So same thing. These two is not superposable. They are non-superposable or non-superimposable. Okay. So in this topic, no, in this topic, it could either be superimposable or non-superposable. Okay. They might be mirror image. No? If the mirror image is not superposable, meaning you cannot fit in, tawag ana nga mirror image is non-superposable. But if it will fit in, ang tawag ana nga mirror image is superposable molecule, superposable object. Okay. What are enantiomers? So enantiomers are stereoisomers that are not non-superposable. You have already the word, the superposable and the non-superposable. Superposable, ang mirror image, pwede nimo ma-fit in. Ang non-superposable, ang mirror image, dili siya ma-fit in. Okay. So, what are enantiomers? Enantiomers are stereoisomers that are non-superposable sa mirror image. So, its relationship is between the pairs of the object. Under enantiomers, it could either be chiral. No? What do you mean by chiral? From the Greek word chir or hand. No? An object is not superposable on its mirror image. So the other term pag yun, no? From the non-superposable o superposable, napag chiral. So what are those molecules? Which is not superposable? They are chiral molecules. Okay, so what is the relationship between the original and the mirror image? Take a look. This original, this is the mirror image. It is not superposable. Dili siya pwede nimo ma-fit in. Okay. So, pero kung i-rotate nimo siya, this is the original, this is the mirror image. Kaning mirror image, i-rotate nimo ning mirror image into 120. It is now, take a look, pag rotate nimo og 120 kani, this is now kani, og kana. Oh, di ba? They are now, superposable. They are known as a chiral. So a chiral object that lacks chirality, an object that is superposable on its mirror image. So we have already this term. What are enantiomers? They are mirror image. What are superposable? Meaning the mirror image will fit in, the original will fit into the mirror image. While non-superposable, the original and the mirror image will not, non-superposable will not fit in. The other one is chiral. So chiral, meaning these are objects that are not superposable on its mirror image. While a chiral, they are objects that are superposable on its mirror image. Why? Because they have stereocenters. What are stereocenters? We already know that carbon has 4, di ba? Tetrahedral man ang carbon, So, it could have 4 sides, It has 4 different groups bonded to it, That is stereocenters. Stereocenters, center is the carbon. Then, kinahanglan na siya laing group sa ibabaw, laing group sa kilid, laing group sa ubos, o laing group sa kilid. The left side is different from the right side. The upper differs from the bottom. And that is now chiral carbon. Kung na ay 4 different ha, pero kung dili 4 different ang iyang substituent, no, ang attachment niya, it is a chiral. Okay. So, yan na. No? So, for instance, we had this. This is lactic acid, kani-kani. Or that is 2-hydroxy. Oh, diba? This is hydroxy. No? 2-hydroxy. Dua ka OH. 2-hydroxy propanoic. Ano propanoic? 1, 2, 3. Because it is COOH. It's carboxylic acid. Sige lang. Next na po nato ni siya nga topic. Last topic din ng carboxylic acid. No? So, this is 2-hydroxy propanoic. Ano propanoic? Because it's propane, but it is with OIC. It's carboxylic. Na? That is why propanoic. Its mirror image is this. Kaninoy mirror image. Na? So, lactic acid displays enantiomerism. What do you mean by enantiomerism? Meaning, it could displace a mirror image or chirality. That is, its original molecule and its mirror image are not superposable. Dili siya superimpose. Di siya mo-fit in. Nga naman, take a look. One of the characteristic of superposable is if your chiral center, where is now our carbon, the stereo center. Here, this is our carbon. This is now our carbon. If it is here, what will happen? So how many substituent you have here? Now how many sides? Okay, groups in each of side. So we have here, we have the CH3, una. Then we have the hydrogen here. We have the OH. Kanipod, lain po ni the COOH. What happened? Do we have 4 different groups? Yes, it has 4 different groups. Into this is CH3, then hydrogen, second group, then OH, then this one is COOH. No? So, it's a mirror image, but what will happen is this one is not superposable, meaning it will not fit in. So, these two are 2 enantiomers. They are called racemic mixture. Racemic mixture. Ano racemic mixture man? Naa sila lain nga substituent. 4 different. It has a stereocenter. This is your carbon nga na stereocenter. But what happened is they are not superposable. So they are called as racemic mixture. So racemic mixture, the term derived here is from the word racemic acid, meaning cluster. What do you mean by cluster? Meaning it has 4 different sides. Okay. So racemic mixture, a mixture of equal amounts of 2 enantiomers, mirror image only. Okay. So racemic acid is originally given to equimolar molecules. Example for this are tartaric acid, which is needed in the fermentation of grapes to produce wine. Okay, so how are we going to draw enantiomers, meaning mirror image? Okay, take a look here. For this, so this is CH3, CH3, what happened here? CH3, that is CH2, CH3, CH, CH3, COOH, then CH2, CH3. Take a look. This one is the CH3. This is your, what is this? Your alcohol. The alcohol group. That is the C, then your hydrogen, and the OH. OH. Then another na pod, this is the CH2, then this is the CH3. No? So, if you look into the ball and stick, kita nyo mo na mag-ana siya ang positioning. So, what happened here? This is your CH3. Then, another na po ni, kani, ibabaw. This is the CH, then, na OH taas. Then, naana po, yan hiya, CH2 na po ni, then CH3. So, this one, na? So, no? What will differ here? Actually, it is the positioning of the second carbon, the CHOH. No? So, your first position here is your carbon, then this is your H, then OH. Then here, pwede po ng ang hydrogen, pwede po nga ang side. Then OH po nga naa. Na? So if you will have it in a line, it looks like this. Or it looks like this. This is your mirror image of this. This one is the mirror image of this. Okay. So that is for 2-butanol. No? So in butanol, no, there is one enantiomer of 2-butanol. No? One enantiomer like this. Kani lagid siya ang iyang mirror image. Either kani or kani. Mirror image niya is either kani or kani. No? So, alternative representation of its mirror image. So, if we are going to write this into 3-dimensional representation, our stereocenter will be here. Kani, mo ni ang stereocenter. If you look into this is our C na ay CH3 nganhi, napay H, ikaduhang group, tas naa pa kani nga group, ikatulo, ug OH, ikaupat. No? So, this is how you are going to draw, no? It's enantiomer. So, this is now, no? An example. So, for instance here, this is 1, 2, 3, 4. This is, no? Chloro, no? 2-chloro, no? 2-chlorobutane, no? 1, 2, 3, 4. That is 2-chlorobutane. While this is, what is this? No? Representation of this, no? Take a look here. What will be its mirror image for this? The 2-chlorobutane. No? So, let us have this into a line. So, primero is that one. Then you have, after that, that is, this is, you have CH3 here. Then, nganhinga side, kaninga side, that is your CH3. This kananga side is your C. Then, you have, this is your CH3. This is your C. Then you have chlorine. Then you have the CH2, CH3. Kani siya. No? So, ang mirror image ani niya is kana. Mubalhin kaning volcanize. Katubi akong suti yung volcanize niya. Diba ang volcanize niya, if it is now the mirror image, this one is on the what? Left side na. This volcanize here is on the right side, no? And its enantiomer, its mirror image is on the left side, no? And they are not superimposable. Pag anak nimo, dili maigo. Kay kani siya, imbis tuwa siya sa left side, naa siya sa right side. Pag superimpose unta nimo sa mirror image, ang volcanize niya is naa sa left side. So it's non-superposable. So it looks like this also. This is the line. Line structure, and this is our structural structure. So as you can see here, diba, this CH2, CH3 is on the right side, but its mirror image, if you are going to see it, it's already on the left side. No? How about this one? So the mirror image of this kani na pareho ra gyapon ni siya. Pero kani mo transfer nga to sa this from the left to the right. Na? That is why it's handedness. Na? The left hand and the right hand. Na? So if it is originally at the right, na, its mirror image will be on the left. Na? Take a look here. So it's already on the left, its mirror image. So this is now your assignment, no? About how are you going to draw its mirror image of this enantiomer, this letter A and letter B. Okay. Let us move on to, let us look into an example of a drug, which is usually I always drink this, especially if I have a headache, it's ibuprofen. This is the structure of the ibuprofen. Inactive enantiomer kanimo ni siya. But its mirror image is kani, nabali. As I have said, from this is now your right, the volcanist is on the right. Pag mirror image, tuwa na siya sa left. And of course, kaning hydrogen nga niya, muad to put sa right. Okay. So, and it will be, you will see that as HOOC. Okay, mabali man siya. And this one will be H3C, then hydrogen. Wala problema hydrogen kay hydrogen na gina siya. Pero kaning COH, CH3, mabali na siya. It will be H3C. Ang COH, it will be HOOC. Okay. So this is the mirror image of the ibuprofen. And it has this, what is this? R and S system. Okay. These are rules in specifying the configuration of the stereocenter. So the stereocenter, mga bata, that is the center of a carbon wherein it has 4 different groups attached to it. Okay. So what is the R and S system? First is, let us look into its rules, the configuration of the stereocenter. Arrange the group bonded to it in order of priority. The higher atomic number, the higher the priority. Then the second is, if the priority cannot be assigned on the basis of the atoms bonded directly to the stereocenter, look to the next atom or set of atoms and continue its first point difference. Then assign its priority. Take a look. What that is the R and S priorities of common groups. Okay. This is increasing priority. Increasing priority. Meaning, ang pinakataas of priority group is the I. I, then followed by bromine, then chlorine. Pinakataas is iodine, then bromine, it's halogen. Chlorine, then SH, the sulfur group, the OH, then the NH2, the nitrogen. Then this is the carboxylic group, the COOH, Then this one, the nitrogen, the one that contains the nitrogen. This is the COH group, the carbon to oxygen, then hydrogen. So this is, ang pinaka-least ang priority is the hydrogen. So let us now assign the priorities in each group. So letter A, this one. Asa may mas taas of priority here? The CH2OH or the CH2CH2OH. The first point that we are going to look is the difference between difference between OH, the O of the OH, no? O of the OH, then this one. Then kisa may mas higher priority. Of course, kaning CH2, gika man ni siya sa the center carbon. This is yours. This is now your carbon here. No? First point difference is this one. Na? Kani mas higher ang priority. Nga naman, that is OH. Kani, layo na ang OH. Ang next priority ni mo ngani is the CH2. Diba? Kani, ang CH2 also yung next priority, the OH. Take a look. Naa siya sa 1, 2, 3, 4. Ika-fifth. While here, this is now the CH2OH. Kapila na siya priority. That is CH2. Naa na nga ni ika-6 to 8. While that OH here is naanganis ibabaw na siya. This one. Naa siyang 6 to 8. Na siya ang priority. Therefore, this one has a higher priority compared with the CH2OH here. Did you get it? Okay. How about this one? Okay. This is CH, followed by CH2. This one. This is your CH2, followed by this. Take a look with our NH. NH2, naagyapon siya. So, mas higher ang priorities ani compared with this one. So, this is lower ang priority, higher ang priority ani niya. So, you are going to assign here, which will have higher priority. Kaniba or kaniba? Kaniba or kaniba? Okay. So, to assign the R or S configuration of the stereocenter, we are going to assign the priority from 1 highest, 4 lowest to each group of the bonded stereocenter. Second is 1 to 4. Nganong 1 to 4 man? Di ba upat man? Upat makaside sa carbon. Okay, so highest priority, it will start with 1, followed by 2, 3, pinaka-lowest is 4. The orientation of the molecule in space so that the lowest priority group 4 is directed away. Basta 4 gani directed away na siya, sa molecule. As would be, for instance, the steering column of the car. For instance, that car, away, palayo is 4. Ang 3 priorities, 1, 4, it should be project towards you. So, if this is your carbon, padung sa imo ang 1, 2, 3 nga priority. Ay ka 4, palayo sa imo. That is what is meant by this one. So, read the 3 groups projecting towards you in order of highest priority. Start with 1, highest priority 1, 2, 3, then lowest ang 4. So if reading the groups 1, 2, 3, proceed it clockwise. What do you mean by clockwise? Clockwise, unsa ang dinaganan sa clock, di ba, paana? So dinaganan sa clock, di ba, paana? Okay. Dinaganan sa clock. So, kanang opposite sa dinaganan sa clock is counterclockwise. Kanang pagdagan sa clock nga, it's on its way, is clockwise. So, if the reading groups of 1, 2, 3 proceed clockwise direction to the right, the configuration is designated as R. Kung iyang reading is clockwise, it is R. Now, if the reading of the groups, way labot ang 4 ha, 1, 2, 3 ra. If the reading, the groups of 1, 2, 3 proceed counterclockwise, paana, clockwise paana. Okay, that is R. Paana gani ang iyang, ang iyang reading, it is counterclockwise, it is S. Okay, so the configuration is S Latin, meaning left. No? Left, you can visualize also this system as follows. Turning the steering wheel to the right. Paana, di ba? Steering wheel. Turning the steering wheel to the left is S. Paana, steering wheel. Okay, S. Pa-right gani is, palubag gani nimo, pa-right is, na, R. Palubag nimo pa-left is S. Oh, steering wheel na lang ang inyong kanon. Palubag, pa-right, padong palana, right. Kasi may driver gani. Pa-right gani, it is R. Pa-left gani is S. Okay, that's it. Tara. Na? Pa-ana gani, what's that? Kana, palubag. It is pa, left is S. Pa-right gani, it is R. Okay. Na, R, order of priority of groups is stereocenter is clockwise. S, the order of priority of groups on stereocenter is counterclockwise. Okay. For instance, this one, let us assign it a R or S configuration. No. So this is 2-butanol, this is alanine. Take a look. Asa man? Ang priority, 1, 2, 3. Na? Way labot ning H. 4 ganing H per me. Na? So, which is, di ba, OH ang 1? Then 2 ni, then 3. 4 ni siya. So, asa man padulong? No? It is, na? It is, no? Kani, this one. The 2-butanol. This one is, ang pinaka-priority ani is, kanautas priority. No? This one. Okay. Therefore, ang priority ani is, it start with this 1, then 2 and 3. Okay. Now, this is 1. No? This is 2 and 3. Okay. That's alanine and this is butanol. No? So let us look into the strategy. So view each molecule through the stereocenter along the band of the stereocenter to the lowest priority group. No? The order of decreasing priority about the stereocenter in the enantiomers of 2-butanol is, it is OH, then CH2 for the 2-butanol. OH, H2, CH3, then CH3, then H. This is 1, 2, 3. No? Therefore, the view in the molecule along the CH with the H pointing away, because your H is what the least priority is for. Ang 1, 2, 3 is along towards you, then the 4 is away from you. Okay. Na? So the reading of the 3 groups 1, 2, 3 follows the clockwise direction. Okay, here. This is start biya ka og OH, no? Then CH2, CH3, then kana. So unsa may positioning paana? It is clockwise. Therefore, if it is clockwise, this is R2-butanol. Did you get it? Okay. Therefore, the configuration is R and this is enantiomer is R2-butanol. Na? So, the order decreasing priority in this enantiomer alanine is NH2, 1, COH2, then CH3, 3, then H. Let us view now the molecule. Okay, this 1, no? Then this is 2, and this is 3. So it's still clockwise. No? Paana man ang iyang, way labot ang 4, kay away man na siya. Meaning, pero kung 1, then 2 nga niya, it is, no? That is counterclockwise. That is, kung nga niya is 1, then 2, 3 nga niya, if it is 1, then 2, 3 nga niya, paana, no? Kung pa-counterclockwise gani, it is S, no? So that is what is meant by R. R is clockwise configuration, while S is counterclockwise configuration. So assign this, no? This is glyceraldehyde. Where is the stereocenter? This is your stereocenter. Kaning C, nga niya. And this is assign now, which is the highest. Okay, that's for the glyceraldehyde. Now, here it is. This is COOH is 1. Oh, not this one. This is the simplest form. No? Where will be your carbon 1? Na? Carbon 1. No. 1, 2, 3. Okay, this is 4. No? So here, balik ka nga mo sa here. No? That is OH1. No? Then 2 ang COH. Then CH3. CH3, take a look. There. Take a look. Let us have it here. This is the OH1. This is 2. And this is 3. So 1, 2, 3. It is counterclockwise. Therefore, this is S. S glyceraldehyde. Okay, that is what is meant by R and S configuration. And we have now the ibuprofen. Ito itong example ganina. So that is, this is the stereocenter, the carbon stereocenter here. No? This is 1. Then kani ang 2, and this is 3. Therefore, paana siya. It is along the clock movement. Therefore, it is R ibuprofen. Pero kung kanipod siya, this one, this is 1, and this is 2, 3. Against the clock, the movement of the clock, therefore, it is S ibuprofen. This is inactive enantiomer, and this is the active enantiomer of ibuprofen. So what is important is when you see the name such as S and R, for instance, S naproxen or R plavix, you realize the compound is chiral, and that compound is not racemic mixture. Rather, it is a pure enantiomer, pure mirror image. So we use the R and S to show the compound as racemic mixture. Now, RS meaning in the naproxen na siya R ang configuration, meaning it is clockwise ang direction. The other one is S configuration, counterclockwise direction. No? So let's look into how many stereoisomers are possible in the molecule. So how are we going to compute it? So for a molecule with n stereocenters, meaning daghang stereocenters, daghang C, nga pwede nimo kuhaan og upat ka different groups, that is stereocenter. The C which has 4 different groups, that is stereocenter. Okay. You will have a formula of 2n, 2 raised to the power of n. For a molecule with 1 stereocenter, pila man ka stereoisomer siya? 2 times 1 is equal to 2. Meaning, sa molecule nga duha ka buk stereocenter, pila ka stereoisomers ang possible? Duha. 1 pair of enantiomers are possible. No? For molecule with 2 stereocenters, you have a formula of 2n, that is 2 times 2 is 4, meaning it has 4 stereoisomers, 2 pairs of enantiomer is possible. For molecule with 3 stereocenters, so how many maximum stereoisomers? We have 2 to the power of 3, that's 2 times 2, 4, 4 times 2, 8. Therefore, there will be 8 stereoisomers, meaning 4 pairs of enantiomer is possible. So that is counting how many stereoisomers are there. How are you going to have it? Tanaw ninyo kung pila ka buok stereocenter. Kung naay usa ka stereocenter, duha ra ka stereoisomer. Mirror image niya. Kung naay duha ka stereocenters, na siya yung upat ka stereoisomers. Kung naa kay 3 stereocenters, meaning na kay 8 ka stereoisomers. Okay? So, for instance, let us consider this 2,3, 4 trihydroxybutanol nga molecule. Pila man kabuk stereocenters nga niya? Be, kwenta ta. Kung nganita, kani-kani, no? This is na ay una nga group niya, di ba? H. Then naapay sunod OH. Sunod kani. Tulo. Then kaning ibabaw. Okay, na? So kani siya na ay stereo, no? Na ay first stereocenter niya. Kanina pod, no? Kani dili pwede kay nganuman ang stereocenter niya is OH, then wala na, no? Kanina dayon, no? Kinahanglan day upat ka different groups. Okay. Next kani, no? Kung kani kadumdumag yun ninyo nga na ay H nga na, then na OH nga na, no? Okay. Na H nga na, na OH nga niya. Therefore, H una. Then OH duha. Kani ikatulo. Then kanang ibabaw mo na ikaupat. So nara siya duha ka stereocenters. Pila ka stereo, pila ka no? Isomers. That is, di ba? That is 2N. 2 times 2, 4. There will be 4, no? Enantiomer or 4 stereoisomers. 4 isomers I mean. Duha ka pair nga isomers, na? This one. Therefore, duha ka stereocenters na ay duha ka stereoisomers or duha ka pair nga stereoisomers. Possible ani niya, na? That is how will we know how many isomers, stereoisomers is present in a molecule. Okay. For this one, this is now its mirror image. So there is one pair. For instance, this one, pila ka stereoisomer. Start na nga niya. No? This is 1, 2, 3, 4. Okay. Una na nga stereoisomer. Stereoisomer nga carbon. Kani, stereoisomer na po ikaduha. That is, this is 1, then 2, 3, 4. So duha ra gyud kabog stereoisomer ani. Meaning pila ka isomers nga niya ato mahimo, no? It has 4. Okay, 2 times 2 is equal to 4. Upat ni siya ka stereoisomers. Stereoisomers A and B are non-superposable mirror image. Therefore, they are enantiomers. Basta dili gani siya, it's left and right, meaning handedness, no? It's not superposable. They are enantiomers. They are just mirror image, but they are not superposable, no? So, A and B, no? Ang una nga stereoisomer, then C and D is ang ikaduhan niya nga stereoisomer. No? So the 2, 3, 4 trihydroxybutanol, no? How many stereoisomers? There will be 4. No? Nga naman, because of it has only two stereocenters. No? Ang A and B is non-superposable mirror image. The second pair, C and D, also non-superposable image. Na? Okay. Actually, this is the erythros. This is trios. Na? Kung sa biochem pa. What? Di nataana. Okay. So what is the relationship between A and C? How about, baliktad. This one. A and C. Di ba they are superposable? Kani. Pag-ana ni mo, bibi. A and C, kani. Dili. Kaya ang OH kanina, ang OH po naarangan ha. Dili, no? Na, A and C, non-superposable. No? Then A and D, dili po. No? It's non-superposable. Pero kang A and C, dili na. Then we have A and C, kani. It's non-superposable. Kani, o kani, sa mirror image niya. No? Then A and D, dili po. Then B and C, dili po. Then B and D, dili po. No? So all of them are not superposable. Okay, with each other. So what are diastereomers? Diastereomers are stereoisomers that are not mirror image. No? But this one, they are stereoisomers because they are mirror image. So, enantiomers and diastereomers. So 1, 2, 3, butane triol has two stereocenter. Kani. This is 1, 2, 3, butane triol. This is 1, 2, 3. Na? OH ba? Pila ka OH? That is why triols. Tulo. No? And it is butane. 1, 2, 3, 4. It's butane. Okay. This one. Then this one. This one. This one. Let us look into the, how many stereoisomers that we have. Let us look into the stereocenters. Let us have the first stereocenters. Kani. No? First stereocenters, that is how many groups? Maklaro ba pila ka stereocenter? Is 1, 2, 3 kana o 4 different groups. That is the first stereocenter kani nga carbon. Ika second stereocenter, okay ba? Yes, this is one group. This one OH is another group. This is another group, and this is another group. How many stereocenters? There are 2. Therefore, how many isomers? We have stereoisomers. We have 4. So that is why we have 4 here. So here, which stereoisomers are pair of enantiomers? Kanang mirror image niya. Asa ani? Ang diastereomers are not mirror image. So kani, take a look. A and B are what? They are mirror image. Diba kani mirror image na siya. Kani C and D are mirror image. Okay. Lain po ng superposable o non-superposable. Okay. Kaning duha, A and B, they are not superposable. C and D, they are also not superposable. Okay, here, this one. Is there, in this molecule, naa ba siya dili mirror image? Okay. Kani A and 2, is it not? It is not a mirror image, diba? Kani. Therefore, 1 and 2, they are diastereomers. Then, kaning 2 and 3, they are mirror image, meaning they are enantiomers. 1 and 2, diastereomers. 2 and 3, it is enantiomer. 3 and 4. 3 and 4, it's not a mirror image. They are diastereomers. Okay? 1 and 4. Oh, it's a mirror image. Then 1 and 3. 1 and 3. It's a diastereomers. It's not a mirror image. Nga naman, ang OH na nga ni, kinala mabali na ang imong pre-ani na kaning 1 and 2, they are not mirror image. Kaya nga naman, ang mirror image ani niya OH na HO nga ni, kinala OH kanhi. Then H po nga to speakas. OH dayon nga to speakas kani. So it's not a mirror image. The 1 and 2 is not a mirror image. They are diastereomers. Why? Kani, okay ni siya, mirror image ni siya. Na carbon 3. Ang carbon 2, it's not a mirror image with 2 because your OH should be here on top. This will be HO here. No? That is what is meant by diastereomers and enantiomers. Enantiomers, they are mirror image, while diastereomers, they are not mirror image. No? Stereoisomers that are not mirror image. Okay. So, the diagram shows relationship among 4 stereoisomers. Okay, that is 1 and 2, they are diastereomers. 2 and 4, they are diastereomers. 4 and 3, they are diastereomers. 3 and 4, it is no, diastereomers. But 1 and 4, they are enantiomer. Dilion niyo ha? 2 and 3 or 3 and 2, they are enantiomers. Okay, that is how it looks in the diagram. Okay, so here in problem 6.4, this is an assignment or a quiz na na to. I will just post it. Na? This will come out. Okay, so first thing is you look for the stereo centers. Where is the stereo centers? Kanang carbon, kanang carbon. Okay. Then, tanawan ninyo pila kabuok mirror image. Pila kabuok ang stereoisomers niya. What's the formula? That is pila ka stereo center to the N. Okay. So, if it is this one, first stereo center 1, na? Carbon 1 here, carbon 2, pila man ni? This is first group, second group, third group, fourth group. Okay, this is the first stereo center. Another stereo center kaninga niya na this is first group, second group, third, and fourth. Okay, so how many stereo centers? There are 2. So how many stereoisomers? That is 2 times 2, 4 ka stereoisomers. Mo na ni siya ang 4 ka stereoisomers. And you are going to know which pair are enantiomers and which pair are diastereomers. Okay. How about in the cyclic? This one is in a linear. Okay. The structural formula is in linear. How about here in the cyclic? How many stereoisomers are possible for 3? This is known as 3-methyl cyclopentanol. This cyclopentanol. This is cis. Na? So there is a pair of enantiomers. This is the first pair of enantiomer, which is in cis. The other one is in trans, opposite. Okay. Basta gani maging ana na siya, meaning ang iyang positioning is paana, na? No? Pwede paana, pwede paana. Okay, kani. Basta broken line. So this is the first pair of enantiomer is cis. The second pair of enantiomer is in a trans. Okay, no? So carbon 1 and 2. Here, carbon 1 and 3 of this compound are stereocenters. So there will be 2 stereocenter, 2 times 2, there will be 4 stereoisomers. No? The first pair is the cis, and the second pair is the trans. So there are 4 stereoisomers. 4 stereoisomers. So another assignment, this one. This one, you are going to locate the kanang nasa asterisk nga na ka mo locate og pila ka buok stereocenter, no? So here this is carbon 1. Okay, di ba? Carbon 1 ni siya, this first, then second na tapos H kaniya. No? This one. There will be 1 only, no? 1 ka stereocenter kanirangan hiya. Therefore, that is 2 times 1 is 2 kabuk ang iyang na stereoisomers. So, kani maoy iyang usa ka stereoisomers ani. Okay. Then kaning B, how many? There will be kani imong first carbon nga stereocenter. Then second, so naay duha. So 2 times 2, there will be 4 stereoisomers. Kani, there will be 4 stereoisomers. No? So here, this is another assignment. No? So you will be the one to mark where will be your stereocenter here. Another one here is molecules with 3 or more stereocenters. Kani, there are 3 stereocenters. That is 2 isopropyl 5-methyl cyclohexanol. No? Therefore, there will be, if there are 3 stereocenters, pila man kabuok ang iyang stereoisomers. There will be, if it is 3 times, na, that is n, na, that is n to the power of 3. That is, you will have how many? No? There will be 8 here. And this is another one. No? So 2n man na siya, 2n rule. That's 2 times 3, there will be 8. 2 times 2, there will be 4. 2 times 4, there will be 2 times 2, 4. 4 times 2, 8. 8 times 2, it will be 16. That is in the computation for the stereocenter. No? Example of a chiral drug is this one. This is an antibiotic which is erythromycin. No? Such as penicillin and erythromycin. No? These are human drugs for antipyretic. No? Aspirin is a chiral, while penicillin and erythromycin, no? Antibiotics, and the drug captopril. Do you know what is captopril? If you have sudden increase in the blood pressure, what happened is you need to take that captopril. That is lowering of the blood pressure in an instant. So that is being placed underneath the tongue for a few minutes, and after that, this will lower those who have a sudden increase in the blood pressure. So that is captopril. This is very effective treatment for high blood pressure and congestive heart failure. And all of these are solved with the SS stereoisomers, meaning the configuration is S. Na? Not R, but S. No? R is clockwise, so S, it is in the counterclockwise configuration. Okay, this is now the cup top ring. So large drugs, no, sold in a form of racemic mixture. No? An example of this is the ibuprofen, no, which is used as, no, especially if you have headache. Yes, and that is, no, aspirin. No? Another one, no, these are, no, these are chiral drugs. No? And, no, as of the moment, there are still plenty of drugs which is being, no, established if it is in the enantiomeric form. Okay. For instance, this is cholesterol. Na cholesterol ni siya. Tanawa rang cholesterol. Pila ka stereocenters? Grabing cholesterol. Na ay 8 ka stereocenters. So pila ka stereoisomers? That is na N, di ba? 2N. That is 2 to the 8. So pila ka book stereoisomers sa cholesterol? 2 to the 8, that is 2 times 2, 4. No? 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 72. 72 times 2. Wa pa ha? Pila na to? 8 pa na? 72 times 2. Pila man? 72 times 2, 144. 144 times 2. So it is 288. 288, can you imagine? There will be 288 stereoisomers for cholesterol alone. No? So that is why cholesterol is a very complicated molecule with 8 stereocenters. So what do you mean by optical activity na in the laboratory? Hey. Actually, optical activity has something to do with plain polarized light. Now, this polarized light is, it's a sort of, in a form in the polarimeter. What happened if we are going to place a substance in the polarimeter, and once a beam of light is being passed through, what happened is, if the plain polarized light, polarized light will turn to the left or will turn to the right, that is what is meant by its optical activity. Pero kung di siya ma-turn, meaning it has no optical activity. So this is a polarimeter. No? It's in a tube. Now what happened is, this is your light source. Now this is your sample tube. Okay. Tapos ibutang ninyo na ang ibutang ninyo ang sample ninyo nga. So if and when your polarized light will turn to the right or will turn to the left, meaning it is optically active. The plain polarized light. These are light with waves vibrating in parallel planes. So what happened here? This is polarimeter is your analyzer. If the substance has optical activity. So when a solution of optical active compound is placed in the sample tube, butang nimo sample tube, so it rotates the plain polarized light. Kung it will turn into clockwise, the rotation is to the right, meaning it is dextrorotatory. But if it will turn to the left, meaning that substance is levorotatory. So if one enantiomers is dextrorotatory and the other one is levorotatory, this kind of mixture are known as racemic, or they are achiral compounds. No, they do not display optical activity. No. So what happened here is that symbol alpha here is the specific rotation. A specific rotation. Just remember, if it is dextrorotatory, you can have it, no? Dextro meaning it will turn the polarized light to the right, no? Levo, it will turn to the left. Okay, so you can specify here as positive, no? Then the negative minus sign, the positive sign for dextrorotatory. Levorotatory, it will be negative. So for instance here, they are the same lactic acid, no? Pareho sila lactic acid, no? Pero mag-differ di siya sa configuration niya, no? This is an S configuration, no? What is S? It is counterclockwise ang iya, no? Di ba kani 1, then 2, paana, 1, 2, 3, paana. It's counterclockwise. Then its optical activity is it will turn to the its level, turn to the right, so it's positive. This one, it's a level, no? This is to the right, no? Luma, no? To the right, ganit na siya. To the right, it is dextrorotatory. To the left, it's levorotatory. Okay. Therefore, this one, no, meaning it's positive, it is to the right. It turns to the right. This one, it turns to the left. And this is this is clockwise and level. This one is clockwise but to the right. Okay. So the positive enantiomer of lactic acid is produced in muscle tissue. So take a look, line siya. Though they have the same formula, but they will differ in its what? Configuration. While the negative is found in the sour cream and sour milk. Okay? Yeah. So what is the significance of the chirality in the biological world? So except for inorganic salt, few molecular weight organic substance wherein most of the plant and animals are chiral. Now, so this is an example of this. This horns of the African gazelle, now chirality. One horn is the mirror image of the other. Okay. So in the biomolecules, an example for this is the chymotrypsin. This is an enzyme in the intestine that catalyzes digestion. This is chiral molecule. Chymotrypsin, take a look, it has 251 stereocenters. So the maximum stereoisomers possible is 2 to the power of 251. So perting daghana siya stereoisomers, no? Fortunately, nature does not squander its precious energy on the resources. No? What is necessary is, though they have the same structural formula, but they will differ in the configuration. At the same time, they will also differ in its function. They will differ in its uses. Okay. So how does an enzyme distinguish between molecules and enantiomer? So an enzyme we already know that enzyme hasten up. No? This will hasten up the catalytic na reaction. Na? By enzyme are important in, especially in the different biological reaction, because this will hasten up. Yang ipapaspas, speed up. Okay, so this is an enzyme surface. We have the glyceraldehyde here. Your glyceraldehyde has two configuration, that is the R and the S. No? The R and the S. This is the R glyceraldehyde and this is the S aldehyde. Okay. Same thing with the ibuprofen. It has the S configuration. Tanawa, kani ang S configuration, it is ibuprofen. Na? This one, the naproxen, S configuration also. No? Pero kaning, mostly ang R are inactive. Kasagari yun, ngani kaning mga for medicinal, it should be in the S configuration. So the S enantiomer are closely related to the analgesic naproxen, an active pain reliever. No? So as a summary, what are mirror image? Meaning if you look into the reflection of the object in the mirror, it looks its image. Now the original image with the mirror. That is why it's so-called mirror and image. What are enantiomers? Enantiomers are pair of stereo isomers that are not non-superimposable mirror image, meaning it cannot fit in. Na? What are racemic mixture? They contain equal amounts of two enantiomers and does not rotate the plane polarized light. What are diastereomers? They are stereoisomers, but they are non-mirror image. So, in enantiomerism, no, an object which is non-superposable on its mirror image are known as chiral, no, or handedness, left and right. No? Mirror image, pero dili sila superimpose. So a chiral object lacks chirality, handedness, but it is superimposable to its mirror image. So most common causes of chirality on organic molecules, of course, because look into the tetrahedral carbon. No? Okay, so look into its stereocenters. What are the S and the R and the S system? No, it will depend on its, no. R is, what is R? No, if it is clockwise, the S configuration is in the counterclockwise. How will you know how many stereoisomers you will have? Using the stereocenters. No? So it has a formula of 2n. Okay, this one. So what is that light that will predict its optical activity? It is the plane polarized light. It is in the polarimeter. Okay, so you will know if it will rotate to the left or to the right, meaning it is optically active. No? So if a compound rotates the plane clockwise, it is dextrorotatory. If it will turn into counterclockwise, it is levorotatory. So each member of pair of enantiomers rotates the plane polarized light in equal number of degrees. Equal. Kaya nga naman, pag sum mo, it will be 0. So both in opposite direction. So an enzyme catalyzes biological reactions of molecules by first positioning them at binding sites. So an enzyme with bind site specific for three of the 4 groups in the stereocenter. No? Kinahanglan yun na agi siya to look at different groups, no? Because nga naman, asa siya mag-bind sa 3, no? 3. Mostly kay ang ika-fourth group is H. Okay. So that ends our chiral about handedness. Thank you for listening and a pleasant day.